Okay, ladies and gentlemen, welcome to the second talk in the Innovation Lab. My name is Stanislav Šiška and I am just moderating this session. In current IT world, we hear a lot about containers, microservices, DevOps toolchain, and so on. And these words are getting through the startup world, through the enterprise world. I have the pleasure to welcome our experts in the Kubernetes area, Michal Zerola and Netočný, who will tell you how Kubernetes fits into these buzzwords and how you can leverage Kubernetes in your daily work. Handing over to you.
Thank you. So I'm really glad that you came in with such a high expectations, and I hope you won't be disappointed. So let's go ahead. We will be talking with my colleague Adam about the Kubernetes, and we try to fit it in 60 minutes. The idea is that I will talk about the fundamentals, probably in 20 minutes, then I will hand over to Adam, who will walk you through the more practical examples and show you more hands-on the stuff. So let's start with the basics. So what is the Kubernetes? Kubernetes is, with one sentence, an industry-leading orchestration platform. It's something what should help you to run and deploy and orchestrate your applications. The word Kubernetes comes from the Greek. It means the helmsman, someone who is steering the ship. And as you can imagine, the ship is something what is carrying your applications. The Kubernetes is powered by more than 15 years of experience at Google, although the Kubernetes itself is not something what was running or have been running in Google, since you know that Google is using a Borg system, but the Kubernetes is inspired, and a lot of things at the Kubernetes comes from the experience, white papers, and all the stuff what Google has behind, and together with the other tech companies like Red Hat and other contributors, they created this incredible project, and it's one of the most active projects on a GitHub. As you can see, it's governed by Cloud Native Computing Foundation. It's mostly written in Go, and it has every, I would say, 3 or 4 weeks new release. It has more than 1,600 contributors, so it's very active. Okay, so what is Kubernetes giving you? Why should you use it? First of all, the Kubernetes is orchestration platform which is completely cloud agnostic. So it doesn't matter whether you run the Kubernetes on top of the AWS, Azure, and other like Google Cloud providers, or even if you run it on bare metal. This is something what Kubernetes completely shields you, and once your application is built for the Kubernetes, it doesn't matter if you reinstall and deploy the Kubernetes on another infrastructure, it will still work and you don't have to change your application. That's, I think, one of the biggest benefits for you, that it shields you from the underlying infrastructure. What do you have to do if you want to use the Kubernetes? So there is some contract, right? The first and foremost, your application has to be designed as a container. So you create and ship your application as containers, and this is the, let's say, the language or the contract you have, because Kubernetes talk with a containerized language. Very briefly, I guess most of you already know it, but what containers are good for and what does it mean? So it's a packaging system or lightweight package. How you put together, ship and deploy your application. The idea of the containers is that you basically fit together not only your binary, not only your real application, but also all the dependencies your application depends on together, and you give it to someone else who should be able to run it independently on the underlying system. That's the biggest advantage of containers. You can look at it as something like the virtual machine, with exceptions, and the containers are much more lightweight. Because they benefit from the single underlying kernel and things like namespaces, C groups, and so on. So similar isolation. It gives you similar isolation like the virtual machines, but much more lightweight. Coming back to the Kubernetes, what are the main features? So first of all, the Kubernetes are built inherently with the failure in mind. What do I mean by it? That sooner or later, Kubernetes expects that something is going to break down. So either your application will become unhealthy, you will experience the network issues, your EC2 machine will go down, or anything is going to happen which will prevent your application running smoothly. This is built in mind with Kubernetes, and if you also build your application accordingly, it gives you the automatic self-healing. So it constantly will monitor your application and self-heal as much as possible if something goes wrong. Another nice feature is the horizontal scaling. So as you can imagine, Kubernetes expects that your application can run in multiple replicas, and if there is a higher demand for the resources, the higher load comes in, the Kubernetes by itself will scale your application up and down depending on the current demand. It does automatic bin packing for you. What does it mean? Kubernetes knows what kind of resources your application requires. It does know what kind of resources in terms of the underlying infrastructure you have, and it creates an optimal plan for you where your application and what application and where should be running and placed. So it does this bin packing for you, and it constantly checks your underlying infrastructure and matches the schedule according to the current demand. Then it gives you the service discovery and load balancing for you, so the application can find each other and communicate together in a nicely fashion. It gives you the rollouts and rollbacks basically for free, so you can easily deploy a new version of your application and something like a canary deployment, and if it doesn't work out, it can roll back automatically. And as I already said, it supports most major cloud providers, even the bare metal. One more thing I would like to mention, from I would say more than a year of experience from other side, what we think is that from the developer point of view, the Kubernetes changed the way how we look at the design of the application. Because let's say in a traditional war, as a developer, you create an application, you ship it to ops guys, and you kind of expect how the application is going to run. You give it maybe some cookbook to the op guy, but you never know exactly what's going to happen because it's like a different world. With Kubernetes, you know exactly how the Kubernetes are going to treat your application. You know how to design it in a way that you try to help the Kubernetes to orchestrate it as nicely as possible, and it really connects these two worlds together, the ops and dev world, and you design the application differently in such a way that it runs much more smoothly. That's our, let's say, takeaway after the more than a year of Kubernetes. And there is also a cost benefit of running the Kubernetes. So what I want to highlight on this is, so if you look at running the things on bare metal, what do? So you basically scale your resources based on your high demand. So you know that, okay, I have a high demand for the resources. Let's say at 3 p.m. you design your resources in such a way that you can handle this demand, but most of the time you are not going to reach this high demand coming. So you basically have enough resources and you pay for the resources which you don't use most of the time. If you are using the elastic infrastructure beneath, like for example the AWS or another cloud provider, and with the help of Kubernetes, you can dynamically spin up and spin down the resources based on the demands, and you actually pay only for the actual requirements when the demands come. So this is like a cost benefit you can get by a combination of underlying elastic infrastructure with something like Kubernetes, which can add or remove the resources based on the needs. Now, how does the architecture from very high level point of view look like? So as you can imagine, it's a distributed architecture. There are like three major high-level components. So one is something what is called etcd. It's key value database where Kubernetes store the state, the current state of the system. Then there is one or more master nodes where the main reasoning of the Kubernetes happens, and there are the worker nodes. Worker nodes are actually the nodes where your application is deployed and where the application is running. And if we look more close into the parts of the master nodes, or next slide, how the architecture looks like from the service point of view. So on the left side, as I already mentioned, there is the key value database where the state is stored. Then in the middle, the rectangles represent the main parts, the main building blocks of the what's running on a master node. So if we start from the top, there is the API server. So the Kubernetes talked over the REST API to the world, and by the world I mean either the user who want to communicate with the Kubernetes, like you want to deploy application, you want to check what's running, but also other worker nodes who communicate over this API server with the master one. Then there is a scheduler beneath. This is the component where the reasoning happens. This is the component which creates the schedule for your demands for your application based on the resources it has. It computes this schedule. This is where the bin packing happens. And there is a control manager. It's something what basically checks the current state and the computed state and tries to make that the things are running as computed. On the right side, there are multiple worker nodes, and every worker node has something what is called a kubelet. Kubelet is a service, a component which checks what is the required state on that current worker machine, and it just makes sure that all the applications which are supposed to run on the machines are running. There is something what is called kubeproxy, which takes care of the networking. The Kubernetes itself gives you the software-defined network inside, and this is the component which does the communication between the applications. And there is Docker engine, because every application, everything runs as a Docker container, so there is a Docker engine on every single node, including the master one. Now, how do you interact with Kubernetes? So, from the most low-level point of view, you can use the command line tool, which is called a kubectl. It's the most thin thing on a picture. So what is it? It's basically something like a modern SSH. So currently, if you want to do something, what do? You SSH into some node, you check whether the service is running, you start it, you shut it down, and so on. And instead of using SSH, you can use kubectl. So with kubectl, you communicate over the command line with Kubernetes, and you check what should be running, what's the state, and so on. It's the most low-level tool, probably. Then there is a package manager called Helm. Again, a command line tool called by the same name Helm, and you can look at it as the same way as you look into the RPMs or dep packages in Linux world. So basically you pack all the resources together into something what is called a chart. You deploy it using the Helm, and all these charts together, created as one package, are there to create basically your application. And most high-level thing is the Kubernetes dashboard. All of these tools, with Adam show you more closely, is basically the UI interface on top of the kubectl. Now, there are a lot of resources what Kubernetes provides you, and we don't have time to go through all of them, but for someone who didn't work with Kubernetes, what you should imagine if you want to understand how does it work. So we would just go with very briefly with few of them. So one is called the deployment. It's the type of the resource. What does it mean? So imagine that you are going to deploy couple of replicas of your application, which you have already packaged and created a Docker container for. the Docker container is not the most granular thing what the Kubernetes understands. The Kubernetes understands something what is called a pod. Pod is nothing more than just a collection of couple of containers deployed together. And the reason why the pods exist is that there is sometimes there is a reason to package or to couple more containers together, because you want them to share the ports, network interface, and local drive. So you put your application package inside the Docker container, either itself alone or together with some other pod together, another image together in something what is called a pod, and then you just instruct how many pods do you want to run. This is something what is called a replica set, another abstraction on top of the pods, and finally you package all of these into another abstraction, finally the last one, which is called the deployment. On the right side, you see the YAML description of these three hierarchies. If you look somewhere in the bottom, you see the description of the container. In this case, we put there just the margin estimator API, the name of the image, the version. Then you say how many replicas do you want. In this case, it's number 2, and you package it all in this YAML format together. And this is what you basically send to the Kubernetes API. Then Kubernetes API will understand it, and it will grab the image and run it in 2 replicas for you. Now, imagine you have this, then you start to think, okay, now I have 2 replicas of this application. I have probably some other replicas of another application. I need to talk together with them. How do I do that? As I already just briefly mentioned, there is something like a software-defined network. So you probably start to think about, okay, I am going to get some IP addresses for these pods, and should I know the IP addresses? Where should I connect, and so on? The answer is no. The Kubernetes gives you another abstraction, something what is called services. It's a service discovery mechanism where Kubernetes gives you another abstraction. It gives you the stable namespace, the stable domain name for your set of pods, for your something what is called a service. And all you have to know from application who wants to communicate with another application is this single name, the DNS name. And what Kubernetes does is that they will make sure where the underlying pods are running, how the traffic goes directly to the pod of this service, how the load balancing will happen. All of this is hidden under the cover. All you have to know is just this discovery name on the DNS level. So maybe the last one, what's worth mentioning, because we already touched, is this horizontal scaling. So imagine now that you want to tell Kubernetes, okay, now I'm interested in scaling the application based on the CPU load. So what you do is you create another resource, another YAML file like this, where you say create a horizontal pod autoscaler, which would check the CPU utilization of pods, and if it is more than 50%, just scale up. And you can say the minimum number of replicas, the maximum number of replicas, and that's all you have to do. And the Kubernetes will just scale it up and down based on the CPU, the metrics. Also, there are other metrics you can use. Now, before I hand over to Adam, so maybe a small example, the real example what we are currently working on, it's called the margin estimator. It's an application which business purpose is to provide the ability for the clients to compute the portfolio, to calculate the margins for their portfolio. Right from the beginning, it was designed as a cloud-native application in mind. It is a microservice architecture, and from the language point of view, it's a combination of a couple of things. So some components are written in Java, one is in Go, and the front end is written in Angular. If you look at the picture, how the architecture looks like and how the data flow looks like. So if you look from the right to the left, the incoming data is the data coming from the Prisma over some MQP protocol, and the component called margin estimator loader just grabs this data from some broker, stores it into the S3 buckets running provided by the AWS, and the component in the middle where the brain of the whole system is placed, just takes the data and loads it completely into the memory. The whole margin estimator provides the REST API by the component on the left upper side, this margin estimator API thing, and it's supposed to be accessed either directly by another service or from the JavaScript already mentioned UI, which is served as an from the Nginx server. So there are like two possibilities how to access it, and you will see right now by in real how the application looks like. Maybe just the last word: if there is a single thing you should take away after the meeting, and because you want to start the Kubernetes, is probably this repo, what we have created, and we are working on it, and it's probably the easiest way how to install the Kubernetes, especially in the company. Adam will show you in more details how to take it. It's basically a Terraform installation of the Kubernetes, which complies with all the requirements we have from the GIS and taggings and so on, and this is a thing which we develop. And right now we can continue with something more practical.
Okay, so let's go to the practical part of this talk. First of all, let's go quickly through the repository we have here. So that's our repository where we store our Terraform template, which is used to create our infrastructure. First of all, if you spend few minutes to go through the repository, you will find out there is a quite huge README how to install it. Contains some configuration options. I will not go through it because it's too much for this talk. However, there is also a wiki page here at the top with a setup instructions where you have step-by-step setup guide for the Kubernetes cluster. So let's go quickly. How is it? F11. Okay, let's go quickly through the margin estimator. Margin estimator has also a GUI application, like Michal already said. This GUI application is really simple. I can either upload a portfolio, create an empty portfolio, or I can generate a simple portfolio for my needs. So let's generate a simple portfolio. Once it's generated, I can hit here the calculate margin button. It will contact the API server of the margin estimator and will compute the portfolio margins for me with also some drill downs. You can also edit the portfolio you have here. It's really simple. So that's the application. The API beneath could do also other things which are currently used by other applications like Hedgehog, and yeah, in the future it will be also extended for other functionalities as well. Yeah, that's it. Let's go more deeper into how Kubernetes looks like from the from the AWS point of view. So here we are in the AWS console. Let's make it bigger. So here you can see are all the nodes. We have in our infrastructure we have one master. Oh, come on, why is it reloaded? All right, so let's go down. So we have one master node. This is it. You can see that the Terraform template we are using already contains all the restrictions, all the tags, all rules provided by the company we should comply to. So you can see it does have the application co-center, creator owner tags, and so on. There are also other resources like security groups, but let's go through the nodes only here in this case. So we have one master and 12 another worker nodes here. all are communicating through the master together. And let's go back to the Kubernetes itself. So here you see is the infrastructure, how it looks like from the AWS point of view. But when we go to the Kubernetes, we have multiple tools, like Michal already said. There are the kubectl tool. So when you want to use the kubectl, you just write a command called kubectl. I can, for instance, get the list of the nodes. So nodes. It will list me all the nodes. You can see which one is the master, what is the age of the nodes. In this case, you can see that the master is there already 5 days, but we have many nodes starting and being teared down by the Kubernetes because the load is different in different times of the day. As well as we deploy and undeploy applications, so you can see the ages of the worker nodes are different. Here is one which is which has the same age as the master. However, there are also nodes which are created today, like this one was created 6 hours ago. Let's go to another tool we have. It's the Helm package manager. So right now, what I'm showing you actually is the product development cluster we have. So it's the cluster we use, we share with all other applications in our Risk IT product. So you will see right now when I hit here Helm command and the list subcommand, you will see there are plenty of applications. There is, for instance, application MDH. There are also other applications like Dave margin estimator, that's the one we are interested in, but also somewhere there is Dave API, for instance, here. So it's the Dave application itself. The last tool we have here to communicate with the Kubernetes is our dashboard. Here as well I can, for instance, go through the nodes, and we'll see the exactly same result as with the kubectl, because it's using at the backend side is using the same API server to get the same information. However, this is much more useful because it's in GUI form and it's easy to use. I can quickly show here is the master node. That's the one. I can also open, for instance, one of the nodes, let's say this one. Here you can see in the example of a node what's running on it and how does the automatic bin packing work. So you can see on the node there are plenty of pods running. So these are the smallest units in Kubernetes containing one or more containers bundled inside or tightly coupled inside. In this case, you see that on the node it's running MDH as well as the margin estimator, or probably there is also Hedgehog application running on the same node. So the Kubernetes is really trying to utilize all the resources on the node. There is also chart at the top of the screen, which is showing how the utilization look like. So we can see it's really using here 99.6% of CPU on this node. So it's really trying to utilize everything what's there. In our case, we don't use as much memory as CPU, so it's more CPU here. Let's go through the deployments itself. We go back here to the margin estimator. You can see there is a concept of namespaces on the left side as well. We have multiple namespaces. Namespaces are basically there to create some, let's say, how to call it correctly? Isolation, exactly. Isolation between different applications running in the same cluster or on the same cluster. In this case, we have here margin estimator namespace, but there are also other namespaces for the Dave application, as well as, when I scroll down, why is the scrolling not working? Okay, so as well as other Hedgehog, for instance, Dave application as well. So let's go to the margin estimator. At the top level of the hierarchy, there is a deployment, like Michal already mentioned. Let's go, for instance, through the calclib here. So we choose one of the components. You can see there are others. There is the loader API UI component. So these are the components already shown on the previous image. Let's go through the calclib. In the calclib, we can see that another or underlying hierarchy here is the replica set. The replica set itself controls how many pod instances or so-called replicas are running on the cluster. In our case, we are running in 2 instances to have some fail-safe behavior. So once, for instance, one of the instances is completely terminated or it's unhealthy, meaning it has too many requests to fulfill, we can easily load balance to the second instance, and the second instance will calculate the results instead. When we go, one more thing, at the bottom here you can see is the horizontal pod autoscaler configuration saying, okay, when the CPU utilization of the calclib instance is more than 80%, let's start another one. Everything regarding the replication, like I said, is handled here by the replica set. So the pod autoscaler is here to define just the behavior, but the executor here is the replica set itself. When we go to the replica set, then we are at the lowest level. Inside of replica set, we have 2 pods. One of the pod is for instance, here this one, when I go into it, then I can see what's running inside. So in our case is a single container here. That's the image we're using. This one. It's probably too small. Maybe I can make it bigger. Well, right. So let's go a bit down. So that's the image here. Then I can see what are the environment variables used to start the image. So these are passed to into the Docker container. Then there are some commands, arguments. If you want to redefine the command executed inside of the image, or you want to pass some arguments, you can do it using commands or arguments. And there is the reference back to the replica set. It's also saying here if the container is ready to handle traffic or not, if it's initialized or not. It has also some kind of events, meaning if the container is unhealthy, the Kubernetes will store here another type of resource which is called event, and it can notify you if the container is not ready. When we go back to the replica set, inside of the replica set there is one more thing, which is the service. The service here is the one who stores the single DNS name and does the load balancing. So once we try to use this DNS name inside of the Kubernetes cluster, Kubernetes will automatically choose one of the 2 instances or 2 pods running inside and will automatically load balance the traffic between them. Like Michal already said, the pods are, or the Kubernetes itself is built on the idea that everything will go wrong at some point of time. All the pods are exporting something which is called a probe, a liveness and readiness probe. Maybe I can quickly show you inside here. That's the definition of a single pod, but somewhere at the bottom there is liveness and readiness probe. The liveness probe is there to say is the container running or not inside of the pod. If it's not running, the Kubernetes will simply remove the pod, destroy all the resources associated with it, and will start a new container. There is another probe, which is the readiness probe. The readiness probe is basically just saying, is the pod able to serve the traffic, to serve the requests going through the network to the pod? If not, it can report it, and that's the there is the service, which is, let's go back to the service. So there is the service which is reading the readiness probe and is saying, okay, the pod is not ready, so it has really too much work to do. It reported it, so I will just reroute the traffic to the second pod. So it will really remove it from the list of route table pods here, and will route the traffic into the single pod, or the horizontal pod autoscaler will probably in the meantime start another instance of the pod and will route the traffic just to the new to the one old and one new instance. That's more or less about pod services and autoscaling. Maybe one more thing. So here in the dashboard, you're able to do, let's say, almost everything. So I can probably choose here one of the calculib instances, and I can quickly destroy it. So I will hit here the delete button. It will ask me, you want to delete it? Of course, why not? I have another pod which will be handling the traffic in the meantime. Now if I go to the services and I will check here the calculib service, I will already see that there is another pod running. However, it did not report it yet the liveness probe, so it's in the state initializing. The traffic will be routed. So if I hit here the button, I will still get the result, even if the pod even the pod is here restarting in this at this time. Once it reports the liveness probe, it will also check for the readiness probe, so the pod can be live, but it might not be able to serve traffic at the beginning, so it will check both probes. Once both probes are reported as healthy, it will try to, or not it will try, it will really go and serve the traffic also through the second pod here. That's more or less how you can interact with the Kubernetes. There are also other resources, like Michal said, daemon sets, jobs, as well as stateful sets. We will not go through it because it's really too much for the hour. However, there are also other tools. Let's go quickly through the monitoring we have implemented. In the cluster, there is also running the Prometheus monitoring system. So Prometheus is collecting metrics from different endpoints like API server, scheduler, and so on, and it does know what's going on inside the system. All the metrics are collected and pushed into the Grafana we have here. So these are the live data from the current cluster. When I quickly change here, here is the refresh. I can say, okay, refresh every 5 seconds, so you can see what is the current system load inside of the application. You see here is a peak because the calculib instance is running and, or starting, and it's loading the data from the network. You can see here also disk I/O and network. Calculib right now, the instance we just restarted is downloading data from S3, so you can see here is the peak for network as well. So it's really live data, live monitoring. You know exactly what's going on in your cluster. There are also other views, so you can monitor, for instance, only a particular deployment, or you can monitor only particular pod inside of the cluster. It's really a useful tool. Other tool we already have in the cluster is also FluentD, which is collecting all the application logs in the cluster and is sending them into Elasticsearch. We use Elasticsearch from AWS as a managed service, so we really don't install it anywhere. It's AWS who manages the installation and the nodes for the service. And it also provides Kibana to go and search for the logs. And yeah, maybe that's more or less it, right?
I would say so, because we have reserved the rest for the questions.
Exactly. So if you have right now any questions.
I have. I'd like to ask about the logs here in Kibana. Where do you store the logs? It is inside the Docker images, or it is outside, or from which place it is collected?
So when I go back to the pods view here, every pod does have logs associated with it, so you can really go through it and see what's going on inside of the pod. That's the first stage. So the pods are collected inside of the Docker containers on the standard output. However, we have on each node, we have installed, so when I open any node, I will see here, go a bit down. Here is the FluentD Elasticsearch. FluentD is a daemon which collects logs from the running containers on the host and can basically store the logs somewhere. It can push them to the Elasticsearch, for instance. That's the common use case for most of the clusters running worldwide. Or you can also use another types of databases or even file systems. So we use here the FluentD to store the logs inside of a managed service by AWS, where is Elasticsearch running. So the logs you're seeing here were pushed by FluentD, collected from the container and pushed by FluentD to Elasticsearch running inside of AWS.
Okay.
Maybe I would just add that the best approach, I think, is really to log everything to the standard output. Do not try to create anything fancy, because someone else is going to take care of it. So all you have to do is just to log to standard output, and then with a combination, like Adam said, FluentD, just collect it and give it to something what is taking care of the storage, and then Kibana and other graphical tools on top of it. So it's nothing like log rotate or anything like that I would not promote. I just logs everything to standard output and use other tools which are designed to handle logs.
Any other questions? We have 15 more minutes, almost.
I have a question. So I noticed that you are using one master node and 12 workers, all of them more or less in size of X large. Is there any reason for selecting such big instances, and what is the monthly bill for such a cluster?
That's a good question. So when I go back here, you can see the master one is actually small. It's T2 medium because there is no workload running on it. It's really just the API server and the scheduler running on the master node, and these are just to do the decisions where should I run my workloads. So the actual workloads are running on these R4, M4, and C4 instances. Kubernetes does automatically decide what instance should be started based on the demand. So it's really starting instances whenever it's needed, and also choose the type of the instances we just provided to Kubernetes. I can quickly go here to autoscaling groups. So we have here 3 autoscaling groups defined in the view. Okay, so here are the 3 groups. You can see right now it's starting some C4 instance. And these 3 autoscaling groups are provided to the Kubernetes, and Kubernetes decide what what instance should be started in which autoscaling group. What are the costs? For the autoscaling groups, for the worker nodes in the development account, we are using spot instances. So the costs are actually quite low here. I would say, what is the current spot price? Yeah, in the summary for 2 clusters, I would say, and also we have another tools installed there. We pay $2,300 per week, but it's for 2 clusters, and like I said, other tools like we have there Circle CI running to execute all our builds and so on. So it's no more than $1,000 for such a large cluster where many applications are running. So it's Hedgehog, Dave, margin estimator, as well as market data hub application. And the market data hub application is actually running there in 4 instances right now to satisfy different needs. Like we have testers running 1 instance, so they are completely handling their incoming traffic, incoming requests from the brokers. We have other testers which are trying to do some technical tests like destroying machines and destroying pods inside of it to see how the system reacts and so on. And we have also one development instance there. So it's really plenty of applications there, and it's, I would say, not that much. Probably a single server in the company will cost almost the same for a month.
Any other questions?
Don't be shy.
So who is the brave one?
So what happens in case the master node dies?
In theory, nothing. Because the master node is there to schedule the workloads, but once the workloads are scheduled, the nodes are handling everything, so the traffic as well as the workloads itself. However, once you lose your master, in our setup it's a single master, and on the master is the state as well. So in our case it will be unrecoverable. Sorry. And you have to create a new cluster, completely new cluster. There is also option to run multiple masters, where the etcd instance, which is storing the state, is distributed among these masters. And in that case, if a master dies, another will take over and will do the scheduling and all the decisions needed for the clusters. However, like I said, in our case, when you lose the master, all the applications will be running, because there are load balancers from AWS pointing to the nodes, and the nodes are handling all the traffic.
Any other question?
How it actually works with resource scheduling or utilization on those workers? If you deploy containers, then are you over provisioning, or because can happen the situation when containers load more than you expected? What will happen then if one worker get overloaded?
That's a very good question. For each container you deploy into the cluster, I'm currently in the CalClip, yes. So for each container in the cluster, you are basically creating some hints for the Kubernetes to know how should it behave inside of it. Let's say when I go here, there is a part, I missed it somewhere here, is a part where you define so-called resources. So what do you, here you're basically saying, the pod here, or the CalClip pod here, is able to use 1 CPU and 6 gigabytes of memory. However, in the limiting situation, it is able to take more. What does it mean? If it goes through the limit, the Kubernetes will just kill the pod and will start a new instance, because it knows that the pod is probably misconfigured, or it's not running properly. How does the scheduling choose where to run the pods? It's simple, it goes through the requests only, and it doesn't take care about the limits. The limits are there just for the really limiting situations. If multiple pods on the same nodes are above requested resources, and there are no other resources on the node, it will just choose one and kill it to free the resources for the other pods. So it does not mean that the pod will be running there until it reaches the limit. It just means that after the limit, it's really time to kill the pod.
Maybe if I can just add, because maybe if I understand differently, the question is that if you have not enough resources and you are requesting to start your application, let's say, what Kubernetes is going to do if you are basically over-provisioned. And maybe in this regard, the answer is that the Kubernetes talks to this underlying infrastructure, like AWS in our case, and it will talk to AWS and request another EC2 machine, another resource, because it doesn't have enough. So it will basically run something through what is called a cluster autoscaler, and it will request another machine because it doesn't have enough. So it will take some time until it will spin it up, and then it will allocate the resources on this machine for you.
Another question. No.
I have one more. What if you want to deploy and in some container or some node you have some long-running task? How does it behave? How does it recognize that there is something running and you want to deploy, let's say, a new version of your application? So if you have, for instance, some load balancer there, and on the one node there is something which is still running, and on the second node is nothing running, how should this deploy behave? Is there something that recognizes that long-running task is still running, so it's waiting until it finish and then it update the new version?
No, that's the simplest question. There is nothing like that.
So you must handle that as a developer.
Exactly. When it tries to kill the pod, so unschedule it and replace it with a new one, it's just tries to gracefully stop the container. But if you not, if the container is not stopped at some time, I would say it's predefined timeout or something like that there, right? So it will really kill the container and remove it.
Mm-hmm. Yeah, so the only thing you are providing as a developer of your application are these two checks. One is called is liveness, which says that am I healthy? If I'm not, then Kubernetes will just shut you down and start another one. And another one is this readiness, if you can handle the traffic. And this is the only thing, the only two hints which you give to Kubernetes. And based on this, Kubernetes just decide, okay, that one seems to be running, but it doesn't. It's not that granular that it has enough work. I mean, in sense that it is super busy or not super busy. It just means that yes, it is running and it can handle the traffic or not. And it just makes sure that the same number of replicas as requested is running or not, but in this case, no.
Maybe one more thing which comes to my mind is also that Kubernetes does something which is called rollout. Rollout, exactly. So when you, for instance, try to deploy a new version of your application, you always changing just the deployment here. The deployment has multiple pods inside of it. And let's imagine you deploy a new version of the deployment. So what does this mean for the Kubernetes? The Kubernetes will create a new, or will keep the same deployment, but will create a new replica set we need. So we will have, for a short period of time, we will have two replica sets inside here, for instance, the cloud whip. So we will see here two replica sets. The one will keep the original pods, and the second one will be empty at the beginning. It will create first pod from the new one with your new application, and once it's ready, and once it will be ready, and you'll be able to serve the traffic. At the same point, it will deploy the first pod from the application from the second replica set here. So. Until really the first pod is ready, the old application will serve all the traffic, and all your user needs will be fulfilled at the same time. Once the first pod will be ready, it will try to serve part of the traffic for the new pod, and will create another pod and once another pod is ready, it will kill another pod from the old replica, and it will create another, and destroy another. So it's really doing a rolling update. So for a short period of time, you will have two replica sets or two versions of your application serving the traffic. However, all the requests will be fulfilled at the same time. So you don't have to worry about basically serving requests for your users.
Maybe something similar, what we are also investigating is something what is called API gateway, and for that you can use another third-party thing like Ambassador or even from the AWS, the managed one. And here what you can do is you can deploy two versions of your application, and you can say through the API gateway, okay, route 80% traffic to my old version and 20% to my new one. You can do these A/B testings and just check see if your new version works properly, and then you can just adjust the threshold as needed. But it's not directly handled by the Kubernetes, but by something what is called API gateway.
So I have another question. Could you mention like future of Kubernetes? Where is the technology moving? What features are on the horizon? And maybe if you can compare it to other technologies like serverless systems like Lambdas and so on.
I don't know, I think it's hard to foresee completely the future, but based on the last years, I would say that the Kubernetes is really becoming the standard, the orchestration standard. You can see if you look at AWS, they started with something, Docker Swarm. They started with something ALM, like ECS it is called in AWS, if I'm not mistaken. In latest AWS reInvent conference, they have implemented or they have announced yet that they are going to completely support fully managed Kubernetes cluster. It's still in some preview state, but that's probably the way how they are going to head on, because they see that there is a high demand for the Kubernetes from the community, and not everybody just wants to use PCS or something else. So based on this, I would say that the future of Kubernetes seems to be really like the standard for not only on AWS side, but also for other cloud providers. As far as I know, Azure is also providing the managed Kubernetes itself. If you look at the Docker Swarm, it was also another competitor of Kubernetes, and they have also switched to Kubernetes from their Swarm orchestration thing. As I said, it's hard to foresee, but right now I think it's not a bad choice.
Yeah, for some projects which are deciding to move to, for example, from some web server to next technology, do you think it's Kubernetes a good choice, or they should see far into the future, like, for example, serverless, like Lambda?
Serverless is still, I think, a new thing, and it's not fully standardized. That's what I feel. So I think, at least from my point of view, it's fine to wait a bit of time until the things get more standardized. So what I mean, okay, you have a serverless implementation by AWS, but once you use it, you are stuck with AWS. If you decide to use serverless on another cloud provider, you probably have to rewrite it more or less because it's going to talk differently. The Kubernetes is already a standard, so once first of all, the Docker is a standard. So once your application is Dockerized, it's a good thing because it can be transferable easily to other things. Then the Kubernetes itself gives you the contract, how you talk to it, and once you move the Kubernetes somewhere else and you know the Kubernetes is already there, you don't have to change your application. So I would say the serverless, the idea is great because, right, you basically, it's another abstraction higher. You don't request the machines, you just tell this is my function, what I want to run. But I think it needs a bit of time.
Thank you.
I will maybe add to it that the Kubernetes right now in the version 1.9.6 as well as in the new one 1.10 does have already stable API. It's not changing that much. So for the future, it's really more a standard way how you deploy the application on the Kubernetes. They define all these workloads in the stable API. They have also the horizontal code autoscaling stable right now. They have almost everything is stable right now, so it's no more a project which is some kind of unstable bunch of APIs, but it's really stable, and they're now planning to evolve these APIs into new versions. However, they will be still backwards compatible. And I would also mention that in the past few months they are not really developing anything new. They are trying to make the installations of Kubernetes clusters more secure. So they are really trying to secure everything, trying to use the certificates for every communication inside the cluster to encrypt everything, to lock down everything so the clusters will be safe even without some additional, let's say, user changes or interactions. So that's the main point of the latest versions, like 1.9 and 1.10. So there are almost no new features, but the security was improved.
Okay, we are out of time, so if there is last quick question. If not, we can call it for today. Thank you very much, guys, for a great presentation. It was awesome. Thanks for coming. Thanks everyone for making this presentation happen. So thanks Carlos, thanks Marek. And please join us on Innovation Lab Slack channel. You can comment, provide any feedback or suggest any improvement for the next sessions. Thank you everyone and have a great afternoon.